Here we have an unusual lift. It's about 6 meters long and 1 meter wide. It runs from chains and was installed in 1940. The machinery in the basement is still completely original. Here is the lift on the ground floor with the doors open. But why are the doors so high? They're so high that you can see on top of the lift and into the shaft. Coming up, why the doors are so tall, the unusual chain setup with an animation to explain it, the 1940s machinery, what these switches do, and much more. This lift dates back all the way to 1917. It was recommissioned in 1940 and the machinery still remains from this period. You'll notice a small door in the top right, which is the upper floor, and there's also a basement below. A short bit of history for you. Looking at the wiring diagram, you can see Schlobern Fabrik, which means this building was originally a screw factory. The lift was built like this to carry long metal rods into the workshop in the basement. The bars would have been cut into little pieces, then reshaped into screws. It's now being used for another purpose, which I'll come to in a bit. The chain system is unusual. The chains go up from the lift car, then split and go down both sides of the lift. I'll explain this later with an animation that I created. It wasn't exactly difficult to get the camera on top of the lift. So here are some camera angles of this lift running. Watch out for the two separate counterweights. Here's the lift from the top floor and what I would call a normal sized door. Then we're heading into the basement and some detailed footage of the 1940s machinery in operation.
Outside and the lift goes down. That's what you take on video and make on YouTube. Great. Okay.
Now we're heading into the basement, which is the primary purpose for this lift. It's for the transportation of beer crates and kegs. The motor room, which you'll see in a moment, is completely original from 1940. I can't believe how long this lift is. Who designed this? Who thought of a lift?
Cheese eating guy.
And how many meters? What, 1, 2,
Wow,
3,
at least
4?
5. At least.
I'll say more like 5 to 10. I'm sure you'll agree, it's done very well for the years it's been running, and it's still going. Yes, I found the one on the first floor quite hard to open. You have to get it in exactly the right place.
I am an old leaf and want to live a long life. Don't slam the doors, it will break me. Please treat me with care.
Google Translate came up with something slightly different. It's amusing and coming up later in the video. This is the floor selector, which decides which way the lift needs to travel to reach a call, and when the lift can run with the doors open, which I'll come back to later on. A lot of old Schindler lifts have 2 motors. The one at the bottom drives the main chain system to move the lift. The small motor at the top releases the brake before the lift can run, and it's linked mechanically to 2 other devices. It moves these contacts at the front, so that the main motor is only switched on after the brake is released. You'll also notice a cylinder at the back of the brake motor. This one is linked to some heavy-duty resistors inside the caged area. We're coming to this in a moment. This is very interesting. It's a mechanical shutdown switch. We'll speed up the footage later, which will help me describe how it works. There is a linkage from the cylinder. These 5 bars and springs are switches that short out the motor startup resistors inside the cage. Again, it's easier to describe it later once you've seen it in action. The resistors for the main motor, and the motor is actually called a slip ring motor. The resistors control the startup. View number 2. Let's see everything in action from multiple camera angles. Here is the chain system. The motor is in the basement, which drives the large chain. It's represented here by the purple lines. It starts from the lift car and travels up, then across and down to the basement to the motor. After this, it goes back up and across to a counterweight on the other side. I say a counterweight because there's two of them. It seems the weight of the whole system was too much for the chain and pulley system. To relieve it, a certain amount of weight is transferred to a second counterweight, which runs separately. The second chain system is shown here in blue. The small chain system again runs from the top of the lift car, but it does not go to the motor. Instead, it links directly to the second counterweight. The weight of the lift car is shared between the two chain systems. The difference is, the purple chain system isn't dealing with the entire load, which means the motor and chain diverters last longer due to less wear and tear.
Okay.
Now, why the lift doors are so tall. If you can imagine a beer delivery lorry driving into this area, the crates are about 1 or 2 meters off the ground. To make it easier to unload, you can simply move the lift up to the height of the delivery truck and load the crates directly into the lift. This makes unloading much easier. On the car operating panel, these 3 buttons send the lift to the top, middle or bottom floor. This title says adjustment in German. Underneath it are the up-down buttons that allow the lift to be moved with the doors open. But you cannot just keep going up or down with the doors open, else someone will fall into the shaft. The lift is only allowed to move, doors open, within the range of the landing doors. This leads me to the floor selector and these 2 roller switches, which are linked to the up-down adjustment buttons. In the basement, the landing panel also has these up-down adjustment buttons that I'll mention later on. You'll notice a ramped section around the floor selector wheel. When the lift moves, this ramp activates the roller switches. The roller switches disable the up-down adjustment buttons. They are switched back on in 2 locations. The first location was the basement. The second location is coming up. The lift is now in the deliveries area and within range of the tall doors. If the doors were open, it's now possible to move the lift up and down. When the lift is at the upper floor, the lift cannot be moved because the roller switches now disable that function. Now let's have a look on top of the lift, where you can see the chain system more clearly. You'll also notice the chains are different sizes, with the small chain running from the lift then directly to the first counterweight. The large chain travels from the lift, then down to the motor on the other side, then back up and across to the second counterweight. This device is called a retiring cam. It runs from a motor underneath the lift. When the lift is level with the floor, this bar pushes the lock mechanism to unlock it. To see the counterweights in more detail and the motor that operates the retiring cam, let's have a look into the lift pit. The smaller counterweight at the front is the one that links directly to the lift car. The larger counterweight at the back travels up, over and back down to the motor on the other side. This is the motor that runs the retiring cam that unlocks the outer doors. You'll notice there's one in each corner because there are doors on both sides. The lift car has a steel frame construction, with the floor and ceiling being made of wood. Behind here is the motor, and you'll notice that you can actually move the lift up and down in the basement using these two buttons. Again, it's to assist with the unloading of the lift with the doors open. A mechanical shutdown device. When the lift moves, the rod in the middle rotates, which moves a threaded bar in the middle. Let's watch it in action with the video speeded up. There are mechanical stops on either end, which are calibrated for the lift when it's at its highest and lowest position in the shaft. If the lift goes above the top floor or below the bottom floor into the pit, then the moving bar will reach a stop and will be unable to travel any further in that direction. With the rod still moving and the bar unable to move any further, something has to give. This causes the whole unit to rotate, which now pulls the cable from above. The cable is linked to a switch, which when pulled down, turns off the power to the lift. The summary is, power to the lift is mechanically disconnected. A slip ring motor, which was popular back in the 1940s, as they have more torque when they start up compared to other motors. 3 slip rings. Each slip ring connects to a group of windings on the rotor. The slip rings are used to connect them back to the control cabinet. If we connect a resistance between each winding, this stops one winding sharing its energy with the other windings, which would happen in a cage configuration. This gives the rotor an extra kick, and it has the effect of helping to align. For it to work, resistors are connected to these slip rings. Once the motor is running, the switches behind the cage connect to the resistors to bypass them. In 1940, electronic timers were quite rare, so here we have a mechanical timer. When the brake releases, this lever is also released. But it doesn't drop immediately because this air chamber slows it down. This whole mechanism controls power to the motor and controls the slip ring motor resistors that I mentioned a moment ago. This pushes these springs at the end here, and these gradually push the contacts together, which short out the resistors to give the motor full power. To illustrate this a little clearer, I've added these indicators, and I've emphasized the gap between each contact. Now the sign that's written in German. Let's see what Google Translate came up with. Well, that's great. Coming up is the link to the slip ring motor video. If you would like to watch it, you can click it in a moment in the top right. I do hope you found this video interesting. I put a lot of effort into filming and especially editing these videos. So if you've enjoyed watching, please consider subscribing to the Mr. Matt and Mr. Chay channel. And thank you very much for watching.